0.000042% or something is not a lot of it. In fact, it is rather a minuscule amount of it. But it's also fairly meaningless, of course, unless you know what it is. Unless you're a Douglas Adams fan, in which case the fact that it's 42 is quite exciting. But no, 0.000042% is actually quite significant to me in my work. Let's spend the next 5 minutes figuring out why, shall we? I'm Rebecca Farnum, and this is Ramblings with Rebecca. And where in the world is all the water? Earth is called the blue planet, and by is called, I mean we call it that. I don't think there are others who do, though that would be exciting. Just over 70% of the Earth's surface is covered in water. Now that's a pretty substantial amount. That means almost 3/4. We have more than twice as much water on the surface than we do land. That's pretty good. That means we shouldn't have any water problems, and my degree should be meaningless, right? Wrong! Because you see, of that 70% of the Earth's surface that is covered in water, about 97% of that is saline, salty, and in the oceans, aka not good to drink. If you've ever been swimming in the ocean, you know this. It's just not a pleasant experience. Desalination technologies, through which we take salty water and make it potable, drinkable, and usable for human consumption, they exist and they are improving. We do that with lots of pressure by pushing water through fancy filters and through electricity and chemistry and that kind of thing. So it's doable. We can do it, but it's fairly expensive, even though it's improving. And it's just not all that sustainable from either an economic or an ecological standpoint. So if we go ahead and just set aside that 97% that is saline oceans, we have 3% left that is fresh water. Therefore, preferred for our particular uses. However, of that 3%, of the 70%, 69 of it is stuck in frozen glaciers. And while we're doing a really good job of trying to melt the glaciers, unfortunately, the melted glaciers go into the saline oceans and become saline instead of actually being useful for us. So there's that 69% that's pretty much locked up in the frozen glaciers, and I hope stays frozen. And then another 30% of the 3% is groundwater, which means it's actually stuck in really big reservoirs under the ground. Now, it's not precisely stuck. We can get it out, and there is a lot of pumping that happens. However, pumping groundwater isn't necessarily the best, in that we tend to pump and pull out faster than the natural systems put it back in. So it's like filling up a bathtub, but pulling the plug and throwing buckets out the side at the same time. You're just pulling out way more water than the tap is ever going to get in. And very shortly, the bathtub's going to be essentially empty, and you're going to want more water, and it won't be there. So all kinds of issues with groundwater. We'll talk about that more in a bit. So we've got this 3% of fresh water, but 69% of it is in glaciers, 30% of it is in groundwater. That leaves actually just a little bit less than 1% of the 3% as surface water, as what we think of it. When we tend to say water, we tend to think of rivers and lakes and that kind of thing. So of that 1% of the 3% of the 70%, about 87% of it is lakes, 11% of it is swamps, and 2% of it is rivers. Now, we tend to think about rivers most, but when we focus on rivers, which is of course what most people see, right? If people know water or see water in their daily basis, usually it is a river. I have one flowing by my house. It's where a lot of cities and other water infrastructures get their water from, and what they treat and how they use it to transport and that kind of thing. So rivers are a big deal, and they're very complicated systems. But when we focus only on rivers, we're only tackling 2% of 1% of 3% of 70%. And that's 0.000042% of the Earth's surface and of the Earth's water resources. Which means we're not doing a good job, and we're not actually getting our heads around water very properly. So part of what I've been doing, my master's, is doing these water and food links. Another big part of it is trying to get a grasp on all of the ways that there is water in the world and where all it goes and how we can deal with it.